So is this working? Yeah, so thanks, Robert, for the presentation. So today, and I think as a good segue for what we were seeing today in this fellow colleagues in the panel, we're talking about agentic. So we'll talk a little bit about, is this on? Yeah. We'll talk a little bit about how to scale and what we see as good patterns to be able to scale those agents in a telco. So first, we will talk about those agent patterns, but we will also bring 4 use cases, one of which already in production and scaling in operation. So I think it would be interesting. And we can discuss as well later on things that are on the side of agentic that we usually forget to talk about. And I want to start here because for me, agents, so in a real CSP network, one of the big problems that we find is context, right? So even for people, when they're trying to solve problems, troubleshooting, whether it be engineering or operations, we need to gather information to be able to do our job, right? So for agents, it's not different. So no matter how good your LLM or how potent it is, if you don't provide him with the right context, he will not be able to reason. Or even it will reason, but it will be at the cost of several thousands of tokens to be able to do something that you like as an answer. So in order for us to be able to scale, we believe that there is certain aspects that need to be solved first. Well, you can do agents on top of databases. You can always do that. But it's not doing that differentiation that we're all looking for, right? So we are looking for fault management processes, probably automated through agents, change management processes. So how can we achieve that? And we believe, at least I believe strongly, that we need to set up the context correctly. And this context is about getting information from the full OSS, full network, I mean, according to the use cases, of course. And that means that you have fault information, performance information, configuration information, but with a very specific caveat, which is these need to be mapped to the topology of the network. Because that's what is important for you also as a human to understand how to troubleshoot, how do you do the root cause, what are the impacts of a service, right? So this is very important information. And so this layer of context is also known as digital twin sometimes, or digital shadow, because it might not be like a full twin that is mapping and simulating every aspect of the network, but it's important to have nevertheless. So what's next on top? So building intelligence. If you want to run algorithms, machine learning, predictive, all of that, of course you need a good layer of data. We already know that. It's no big news. But these are also the functions that the agents will work, because not everything will be reliant on the LLMs. Why would we do that? There are things that we know how to do. For instance, if we have a digital twin, we know how to traverse a graph. There are many algorithms out there already out of the box, pre-shipped within the graph technology that we can use and make at the disposal of agents, right? And so the agents will then go on top of agents, of context, of intelligence, and yes, they will take care of the more end-to-end processes, right? So whether it be getting information from the network, like reporting, dashboarding, dynamically, potentially, automating changes in our network, which is something that takes, well, a lot of steps and a lot of teams, as you know, and also fault and incident management. And so the agents will be on top of those 2 layers, we believe. So for us, no agency without intelligence, no intelligence without the context. So very important. And this is what brings raw data to trustworthy action by agents, because otherwise, we don't know what they will be doing. Okay. So let's look a little bit on these 2 bottom layers. So the first is the context, but as I said, is also like a digital twin or digital shadow, which means we bring information as we need for the use cases, for agents and AI to work on top, right? And this is about, like I said before, it's not only, well, bringing data into a data platform, because that we already do, but what we need to do is structure it with context of the network, whether it be the access network, the core network, the transport IP network. We need to bring that information to be aware of topology, and even possibly, or I mean, ideally, to cross between those three domains or even more domains, so that we know, for instance, that certain problem in transmission is affecting certain problems in the access network, because that will be very important for operations, as you might know. And so it's building this layer of information that is able to, for us, be AI-ready and agent-ready as well. And on top of that, enable us to do things like multi-domain, multi-vendor, so having this abstraction of the vendor, first and foremost, but also being able to cross domains. Because my services are not being delivered by a core network or a transport network. They are being delivered across all of these networks, and probably more, infrastructure, etc. It's about how I can do impact assessment. If I know that some node, some piece of my network is not going well, I need to be able to see what are the impacts in terms of customers, of service, who is going to suffer from that failure. Root cause analysis, well, a long-standing problem to do in the operations, right? And so we believe that these components are essential not only for agents, also for humans and normal automation, to be there, to go there and check, okay, I have a fiber cut. I know what are the access network, mobile, fixed, whatever, that is affected by that. And you can forward it to the right team, not having two teams, right, looking at the same problem, which normally a lot of times happens. And the fourth one, I think, well, everyone knows also, here's about what-if analysis. What do we mean by that? So it means that if we copy this digital shadow, digital twin, as long as as far as you want to go, well, you can do simulations on top. We can change the network, run simulations again, and also planning capacity, because we are no longer planning capacity by what we think will be the usage of the network or the load of the network. And this is not only for virtual networks, it's also for fiber networks, access networks, all of that. So very important, and this is the agents world model. So it's on top of this that we believe agents will thrive. Come on. Okay. So what is that? Agents. Typically, or agent orchestration frameworks, as we also might call it. And, well, some people say that they are AI. I tend to disagree. I think they are an orchestration framework that is needled by the AI, by LLMs, right? So we once had orchestration, workflow, all of that. And we need to statically define what these would do, which was, as you all know, we didn't like to do that. And now we suddenly have flows that can be automated, that are intelligent, and know where to go next. That's the benefit, at least in my mind, one of the benefits. And so if we have this twin layer of the context, providing the context, we have this intelligence on top. And by the way, it's not only agents. Don't run to everything will be agents now, because we still have prediction. We still have machine learning to do anomaly detection, which is very good at it. Why should we? So these two are at the disposal of the agents. And then we have, well, several agents. It's like us, humans, right? Some of us are good at scripting. Some of us are good at understanding people. Some of us are good at implementing, designing, whatever it is. We all have our skills. which is what they call it in the agent world. And like I said before, these will be the orchestration frameworks that take care, well, you can use agents to query a database, correlate simple things. But where we feel that we need to scale, and scaling is not only about load, it's also about taking care of processes that we want to take care and automate in the operations and engineering. And so these processes will be taken care of agents, at least in some part. Probably not fully, so we still need human in the loop, and my panel colleagues also mentioned that. Very important how to interact, how to take care, and how to make the two parts working together, and with trust. And so these agents will work on top of tools so that they are able to query, to get information, but also to act. And typically we do this, I mean, these are three. There are more frameworks out there: LangGraph, ADK from Google, Strands, or Bedrock from AWS. Now for the use cases. So best chance is that the working use cases, the differentiating use cases that you see, they are working because they have very good network context. Because otherwise, you might have to did your experimentations with Claude, ChatGPT. If you tell them, make me happy, he won't know what you want, right? But provide him context, and you'll see the difference, right? We all know that. OK, so what about those use cases? So the first one, like I said, already in production, being, well, tested by operations. It's about how we do fault management. So fault management with root cause analysis, service impact assessment, and starting at the very beginning is about capturing KPIs, doing anomaly detection, what we call multivariate anomaly detection. So it's about predicting deviations and synthesizing your own faults, let's call it like that. So next step, grouping events, meaning we group synthesized faults with already generated faults from the network. And I like to give this analogy. It's like putting those in a bucket, right? We are putting things in a bucket that mean the same thing. I don't want 20 alarms on a dashboard. I want one thing that means one thing that I have to do, or someone. Then what's next? It's about stamping that bucket, right? And here is where the agents go. It's not on the full process, because the rest is AI, data engineering, data science. Then comes the agent, because the agent will be provided with this bucket with topology awareness, and this is where it will stamp what he thinks it is, the problem, because he is looking at the topology of the network, is having the fault context, the synthesized faults from anomaly detection, and yes, he is able to provide some recommendation, some pointing of what the problem might be. Okay? Well, of course, you might also be aware of RAG solutions so far. These are also valuable because the agent needs extra information from what he was trained for, right? We all know that LLMs know everything, even Cervantes, Shakespeare, all of that. We don't care about that. But we do need some documentation from the vendor, 3GPP documentation, and probably an information that is like a manual of operations of what we want them, agents, to behave. Okay? So very important. And here, what we're seeing is that at least 70% of the tickets have a ranked root cause, and the mean time to identify, which is, well, we all know that we pass 80% of our time is trying to identify and troubleshoot the problem, and then it's correction, which is, well, not instant, but almost. So that's the first one. Second, it's, and by the way, this was on the core, 4G and 5G core. Another use case, interesting use case in my opinion as well, so is also on the core and the 5G core, but rather than be looking at what the functions of the network are doing, is looking at the communication between those functions. So signaling interfaces from 4G, 5G, so it's getting probing signaling information. 4G, 5G interfaces, well, all of those that you know. It's ingesting that information, putting it in a model that we can, first and foremost, have a conversation with, okay? So we can do things like what IMSS successfully completed the procedures or the other way around, so whatever you want to query it. On top of this, we have anomaly detection as well. So anomaly detection is identifying which of those procedures, because it's a flow, right? The signaling on the core is a process between some of the functions. So we need to identify when one is correct and one isn't. So that anomaly detection is flagging that out. And finally, here comes the agent, which is, how do I troubleshoot? So what does it mean, that anomaly that you've detected, that process, right? And the agent, again, has access to this data model, which he can reason with, he can recommend, and, well, point at least to two or the top two, top three things that the human needs to do to solve the problem, okay? At least in this stage. So here, we see anomaly detection accuracy reached into 97%, which is very interesting. So as you all know, or might know, signaling is loads of data, right? So it's going through all of it to look for problems is a nightmare. And we have at least 10 diagnostic topics already available to ask for the model and be able to do recommendations, resolutions. So hopefully, this will scale out as well. Third, this is one of my favorites, so I also like to work a lot in this particular client. And first and foremost, I need to give some context, because this is a client where we were having a lot of information gathered from RAN, core, to do anomaly detection, looking for problems even before we were having information from it. And because we had that information, we were challenged, how could we do dynamic dashboard reports without building any application? So a new service performance tool just on top of data on a cloud. Well, that's interesting. So here, of course, agents come into play. We have what we call, well, the chat interface. We ask the agents. The agents do the decoding, understand what it's all about, what you want. Again, RAG solutions. They generate the query to time series databases. They execute, and then they generate back what you asked as a dashboard, as a report, as a result, okay? So hopefully, we can also, at a later stage, show you this in more detail, because I think it's very interesting as a use case for agentic. Because this takes away the problem of building new reports. So it's all about change requests that you need to do some application, and that's gone away. It's instant. At last, let's see if I have time. IP change management. So here we're starting to get bold, right? Because, as you know, it's a big process. It goes through many teams. And thinking about how to do things like connectivity between a core IT network, connectivity between two nodes in a DCN. So all of those, how can we take care? How can we manage to do these kind of things? And here, Again, very important, context, intelligence below the agents. Well, we cannot go and just put agents on top of the network and hope that everything will solve, right? Because it won't work. So here, we can see an agent, well, first decoding what the CR is all about, an agent implementing, designing the change on the network, an agent doing the script, an agent validating together with humans, and finally, an agent executing the script, deploying, and even validation after testing. Yeah. So that's one. And that's all good. So 4 use cases, but where does it break when you try to scale, right? So we've talked about the twin, the context, importance of intelligence, and those 2 layers. But of course, many times the less sexier aspects, let's say, of agentic, because you also need to take care of several aspects on the side. I call out 2, but there are more, of course, and I also don't have much time. But just to bring attention to at least 1. So reason monitoring. So we need to take care of agent observability. So we need to observe what the agents are reasoning with. Where did the flow go? Because in a workflow management, you can see the instance running and where it decided and where it chose to go. But not here, right? So we need that visibility. We need to replay the agent flows, understand decisions, and also avoid the drifts of the model. And for this, golden test data sets is essential to run them frequently and expect the same results. And then, as you all know, data sovereignty, security, prompt injection, cost creep. So routing models is important. Many times we hear, what model should I use? The answer is multiple. One smaller model for simple things, the best model for the hardest part, right? And then, like I said, humans and agents, not versus, together, right? It's how they will become together working. And in the end, we all know will be ups and downs with the agent, but we hope to be on this plateau of productivity soon with these use cases, hopefully all getting into production, scaling. And we believe that, also to close out, that the CSPs that will be on top with the agentic are not with the flashiest agents or the ones that were quickest to go on production, but rather those who did the investments on foundations that will enable them to scale, not only in terms of more data, more processing, but rather scale in terms of what the value is for the CSP. Thank you. If you want to know more,